This is the first mini lecture for section 13.2 of the textbook. The slides I'm going to be using are available on Blackboard. I would recommend printing them out if you can and filling them in as we go along. If you're not able to print them out, I would suggest just pausing the video at the end of each slide and copying down what you see. So section 13.2, or 2.2 is called in the syllabus, is about taking some of the things we noticed in the previous section and making them quantitative. So we talked about things like what is a typical score for a data set, or how is the data set spread out. Now we would like to add some numbers to that. We'd like to come up with a way of measuring. We would like to measure the center of a data set, and we would like to measure the spread of the data set along its range. Okay, so if you will, please turn to page 686 of the textbook and look at the data sets R, S, and T. Okay, they all look like they probably represent test scores or something like that, but they all have different centers and different spreads. So R looks like it's, most of the scores are somewhere between 70 and 80. Maybe there's a center around 76 or 77. It kind of tapers off away from there, and there's not many extreme scores. We do have this very low extreme score at 46, and then we have a high extreme score at 92. But most of the scores, the vast majority, are between 70 and 80. S is rather different. It's much more compact. We don't have these outlying scores. Pretty much all the scores are somewhere between, it looks like 67 and 80. And then T is kind of the opposite. It's very spread out. It's very scattered. So you've got not much of a clear center. If there was one, maybe we would say around 85 would be a center. But we have this big stack of 40s, and the data is really spread out there. So we would like some kind of systematic way of measuring, okay, like what is the center? How can we measure that objectively? And we'd also like a systematic way of measuring how the data is spread out. Okay, so in this section, we're going to begin by talking about measures of central tendency. Okay, suppose we have 6 stacks of blocks of heights 4, 5, 2, 3, 4, and 6. So I have a set of stacks of blocks to show you here. Let me zoom out a little bit. Okay, so we've got a stack of 4, a stack of 5, a stack of 2, a stack of 3, a stack of 4, and a stack of 6. And I'd like to answer the question of what is the typical height? Some of them are taller, like the 4, or rather the 5 and the 6 are kind of taller. The 2 and the 3 are shorter. What's a typical height? Well, there's different ways of answering that. One way to answer would be to imagine basically leveling the blocks out. So if I move blocks around among the stacks, I want to keep 6 stacks, but I'm allowed to redistribute them. And I want to do that so each stack has the same amount. And I can do that by taking this block and popping it off and putting it on top of this black stack. And then I can take these 2 green blocks at the top and put them onto the purple stack. And when I do that, all 6 stacks have the same height. So one way to answer the question would be that the typical height is 4, because they all have 4 blocks. Okay, so the typical height is 4. Okay, now notice that 4 plus 4 plus 4 plus 4 plus 4 plus 4 is 6 times 4. So if I add up the 6 stacks of blocks, I'm adding 4 to itself 6 times. That's going to come out to 6 fours, or 6 times 4. So therefore, if I add up the original heights, 4, 5, 2, 3, 4, and 6, if I add those up, I'm also going to get 6 times 4. So one way to get this number 4 that we were looking for would be to simply add up the number of blocks in each stack and divide by the total number of stacks. That would give us that 4. So we can find the typical height by adding up all the heights and dividing by the number of stacks. Okay, and this, as you probably know, is what we call the mean or the average. So the mean or average of a collection of values is x bar equals s over n, where s is the sum of the values and n is the number of values. So think about the average this way. You take a set of scores and even them out by redistributing them so that the scores are all the same. Then the result will be the average. For example, suppose you're talking about a company with workers that all make different amounts of money. One way to define the average would be to say, well, we're going to take everyone's salary and redistribute it so that everyone makes the same amount. Okay, then that same amount would be the average. Or you could think about a sandbox. You know, the sand is heaped up in some places and it's kind of dug out in other places. If you want to decide what is the average depth of the sand, you could do that by smoothing the sand out so that it's perfectly flat on top. Then the depth of the sand would be the average height, or the average depth. Okay, now the average can be a little bit misleading. Okay, this is only one way to measure the center. So let's talk about that. Okay, and again, you should have your textbook out while we're talking about this because I'm going to be referring to some of the data there, and I don't want to repeat it in the slides. So consider the data set R in the textbook. Make sure to take a look at that. It's on page 686. So if we compute the average of that data set, we add up all the scores, 71, 79, 70, and so on, all the way to the last score, which is 76. Divide by the total number of scores, which is 24, and we get about 73.8. So that's more or less in the middle, if you look at the dot plot on page 686. But it's a little bit lower than what we might have guessed. We were talking about something like 76 or 77 as a center. But yeah, this is giving us 73.8. It's a little bit lower than we might have guessed. Okay, now let's do the same thing for T. So again, you add up all the scores in the data set T. You divide by the total number of scores, which is 23 in that case, and you get about 71.2. Now, 71.2 is not really very near any of the data at all. It's kind of in a place where there is some data, but it's pretty spread out. It is not anywhere near what we had guessed the center might be, which would be maybe around 85. So this is significantly lower than what we guessed the center would be. Okay, and what's happening here is you have all of the data, all of the 40s down at the bottom of that data set. Look to the left-hand side of the dot plot. You'll see you've got 4 40s and a 45 and a 49. And what's happening is those extreme scores are dragging it down a lot. Okay, and so that could be very misleading. You can find another example of this on page 690. So make sure to turn there while we talk about that. So on page 690, we have this company where the owner makes $850,000. The assistant manager makes $48,000. 3 secretaries earn $18,000. And the 16 other employees earn $27,000. So in this company, every employee but the owner makes $48,000 or less. All but 2 of the employees make $27,000 or $18,000. But if you compute the average a salary for this company, you're going to get 65,905. Okay, so that's almost $20,000 more than what 17 out of the 18 people make. So that is way more than what the vast majority of the company makes. Okay, there's only one person that actually makes more than 65,905, and that's the owner. So you could say, well, the average salary is about $66,000, and that would be true. But it's also very misleading because the no one makes that much money except for the owner. Okay, so long story short, the average is useful, but it can be very misleading.